Good morning, ladies and gentlemen. Welcome to my new video. This video is going to be about the Chinese semiconductor industry, all this latest developments, all the latest news. This is the update from my previous semiconductor video, and what I'm going to be talking about today is the 5 steps that China is taking to be self-sufficient. So before I start, if you can kindly subscribe, like, share, comment, whatever you can to help promote the channel. If you like my content, you're welcome to join my Patreon or buy me a coffee. So without further ado, guys, let me start with the show. So as an introduction, guys, I'd like to introduce this guy. This guy is called the chip czar to lead the semiconductor self-sufficiency. So he was appointed this year by Xi Jinping, and his goal is to achieve technological self-sufficiency of around 70% by 2025. Currently China is around 18 to 20%, but they want to hit 70% self-sufficiency by 2025. So how are they going to do it? I'll explain in a bit. So his name is Liu He. I hope I'm pronouncing it right. And he was appointed this year, and basically China has announced a 1.4 trillion state program to support R&D and key enabling technologies over the next 5 years. These include semiconductors, artificial intelligence, robotics, 5G and 6G, data centers and cloud and quantum computing as well, and low Earth orbiting satellites. And you can see semiconductors is going to be one of the highest R&D processes in China. All of China is currently focusing on that as a #1 priority. Same way they focused on nuclear weapons during the Mao period, as well as a space program, as well as jet engines, as well as having their own navy, aircraft carriers, submarines, stealth aircraft, you name it. Throughout China's history, they've come up with challenges, and challenges they have easily overcome. For example, there was a huge arms embargo on China, and they could not buy any advanced weapons from any of the countries in the West, so they had to have their own weapons arms program. So now they've managed to achieve greatness with it. They've got their own stealth aircraft, stealth technologies, anti-aircraft, missiles, hypersonic, submarines, navy, aircraft carriers, and they did this themselves really without any help from the West. Same with the space program. You know, China was banned from the International Space Program because they thought China couldn't add anything new to it. But since then, China has pretty much come on a par with the American space program. They've sent rovers to Mars, etc. So pretty much on a par with the Americans at the moment. So you can see the history where China has faced great challenges, they managed to overcome it. But I believe this is probably going to be their greatest challenge. So do you think they can achieve it or not? So let's find out, shall we? So I'm going to be talking about 5 major steps that China requires to be self-sufficient. None of them are in importance. All of them are important in their own way. So I'm going to be starting with having a great talent pool. Because China has never had its own semiconductor industry, the talent pool for its semiconductors is very, very small. China was happily buying semiconductors from America. Before the trade war happens, there was a good understanding that China would continue buying semiconductors from America. That would keep the trade imbalance going, and they did not want to upset Americans by having their own semiconductor industry. So that's probably one of the main reasons they didn't want to push for having their own semiconductor industries. There were companies out there like SMIC, but they didn't have any government benefits or subsidiaries or help from the government. They were pretty much on a private basis, and they were very much far behind companies like TSMC and stuff like that. So there wasn't really much of a semiconductor industry. There wasn't a supply chain. There wasn't a big talent pool in China at the time. All of it had changed after the trade war started, and that's when China realized, bloody hell, we need to have our own self-sufficiency when it comes to semiconductors, because if America turns off the switch, you know, our economy could be ruined. So So this is a very much an important step that China requires to be self-sufficient, because semiconductors is the future. Every IoT item and electric cars and every electric unit needs a semiconductor. And without that, they cannot function, and they cannot be the biggest manufacturer in the world. So they will be hugely hit if their manufacturing is hit in some way. And you can see it with cars right now, with the chip shortage, how much it's affecting not only China but all the electric cars and car manufacturers around the world. A slightest hit in the shortage of chips does affect the economy, the GDP, quite hard. So it's very, very important that China develop its own semiconductor industry, because chips are the new oil, and without chips a country cannot move forward. So one thing China has realized, they do not really have much of a talent pool when it comes to semiconductor technologies and semiconductor talents. And they also want to bring up a whole new generation of semiconductor talent above what they have right now. So a lot of the top universities are now doing courses in semiconductors, and a lot of youngsters can now learn, do degrees about semiconductors. So in about 4 or 5 years' time, the talent pool will be much, much higher than it is now. And it starts from the universities upwards, really, because you can see in America, all of their universities, they have very, very good research when it comes to semiconductors and other top electronic and engineering items. So this is the part where USA actually leads China, but China needs to very much catch up when it comes to R&D with semiconductors. So they are putting a lot of money into teaching in universities, research, R&Ds. So this is going to be the first main step. So the second major step that you need to be self-sufficient, you need a global supply chain based on design and manufacturing and a supply chain. So currently the US leads the most R&D intensive activities, electronic design, core intellectual properties, chip design, and owing to world-class universities, vast pool of engineering talent and market-driven innovation ecosystem. ASML of Holland leads advanced manufacturing equipment, and TSMC and Samsung is at the forefront for wafer fabrication, which requires massive capital investment supported by government incentives, as well as access to robust infrastructure and a skilled workforce. China, on the other hand, is a leader of assembly, packaging and testing, which is relatively less skillful and capital intensive, and is investing aggressively to expand throughout the value chain. So basically you can see from this diagram here that US has pretty much taken over most of the supply chain of semiconductors around the world. And you can see all of these components. It starts with the design aspect, you got the core, you got the IPs, then you got the equipment, and then finally you got the materials. And US obviously excels in the first few stages of the supply chains, and you can see US in dark blue and China is in red. So China is hardly around in the first 4 stages. When it comes to equipment, you can see US owns most of the equipment. You can see very little equipment is owned by China. And China is excelling in the last few stages, but the last few stages are not very important, to be honest. This is where you do all your packaging, you do all your testing, etc. And it's not really that important. The most important stages are the first few stages. So the equipment part is a bit of a problem for China, because they're banned from buying all the latest EUV machines, extreme lithography machines. They are allowed to buy the old generation DUV machines, and but they allow you to make semiconductors 14 nanometers and above. Making them 7 nanometers and below, you need the EUV machines, which China has banned from buying, and this happened from the trade war. So that is a big problem. In terms of materials, China is building its own supply chains of materials, so that shouldn't be an issue. As you can see, China is excelling in that department, but they are lacking in the design aspects or the first few stages, and this is something China is building on at the moment. They are trying to build a full supply chain from start to end where they control everything, and they're not reliant on America or other countries. ASML is the biggest equipment manufacturer, and TSMC, and you've got Samsung, which are the biggest fabs out there. And yeah, they are facing a huge hurdle, guys. I mean, you can see from this graph how much of a hurdle that China is facing. But you've got to understand that this is all a start for China. They're just beginning this supply chain now from beginning to end. They've not been doing this for years and years. This is something the whole country is focusing on right now, and one of the main things they need to get right is the full supply chain. So they have started working on this supply chain, and we'll see how they get along over the next few years. It's not going to be a quick and easy job. It's going to take them a few years to mature. So we'll see how they get along in the next few years. So number 3 in the list is equipment. And as you know, as I've explained earlier on, China is not allowed to buy any equipment from ASML or any other countries like Japan, South Korea. Anything with EUV related, they cannot build. However, they can buy DUV machines, which are one generation below, which means you can produce 28 nanometers, sometimes even 14 nanometers as well. But what China is doing right now, they are trying to build their own lithography machines. And the first lithography machine is actually due for delivery at the end of 2021. And the company itself is called SMEE, Shanghai Microelectronic Equipment. So they've done all of their testing, and they're going to be releasing this machine by the end of 2021. And this will be able to produce 28 nanometers chips. And 28 nanometers chips is actually not bad, because you can see here why 28 nanometers chips are important, because they are pretty much used by a lot of IoT devices, which is Internet of Things, things like 5G, and phones, TVs. A lot of them use the IoT devices, but the latest phones, things like Apple, Samsung, that require 5 nanometers and below, they are what you need an EUV machine for. But 70-80% of the time, regarding the IoT devices, you just need 28 nanometers. And also, you can see some of the examples here. Devices ranging from smart traffic lights, fridges, autonomous vehicles, robots, next generation internet, drones, and then you have human robotics, brain processing, BPU core units are made with 28 nanometers technology. Automobiles, data drone centers, wings, robot data centers with arms and legs. You can see most of the stuff, literally 80% of electronical items need 28 nanometers, or perhaps even 14 nanometers, which I'm going to get to next as well. So even though they have their own 28 nanometers lithography machine coming out, China is also in the prototype stage for EUV lithography machines. As you can see from this article here, they're a lot step closer to microchip independence. They've managed to do a lot of testing with the EUV, and they have a EUV prototype ready, which is able to do 7 nanometers chip production as well. So this is still in the testing stage, and there's no news about when this is going to be released, but I would probably estimate over the next few years, even 3-4 years, because EUV is a big jump up in technology from DUV, and it's not going to be very easy to make. They still have a lot of testing to do regarding it, but there is prototypes in place. Plus also China is also discovering new laser lithography technology that is just they've invented themselves with their own IP. So that also could be a way as well. So there are lots of steps that China is taking at the moment, and hopefully they will come into fruition over the next few years. It's not easy thing to do, but with 1.4 billion population and the whole of China focusing on this, I'm sure they will have some good results coming up in the next few years. So number 4 in the list is mass production. So before they get to 70% self-sufficiency, they're currently around 18 to 20% at the moment. They need to increase the output of the chips they are making, and they're heading in the right direction. And you can see from this article here, China's semiconductor output hits record highs. Beijing boosts local production amid intensifying US-China trade war. So China's integrated circuits surpassed 30 billion units in June, 44% increase over the previous year. So this is increasing year by year, as you can see, but they've also got a lot of projects ongoing. For example, their biggest fab, SMIC, is building a new 28 nanometer fab in Shenzhen, and that's with the help of the government as well. So they're spending a lot of money on that, so that's going to increase production. They're also building brand new sub 40 nanometer fabs as well. There's a couple of, I think there's a fab in Beijing that they're building as well. There's 14 nanometer chips to be expected to be mass produced next year as well. So at the moment, 28 nanometers is something China can produce quite easily, but 14 nanometers is something that's going to be mass producing next year, and that's going to help them get to their self-sufficiency. Obviously they can't build sub 5 nanometers yet, but having 28 nanometers and 14 nanometers would basically be enough to give you that 70% self-sufficiency that China's looking for, because 80-90% of the products, electronic products, require 28 nanometers or 14 nanometers. So pretty much China can do everything it wants with these chips. Only thing lacking is the phones, the latest smartphones. So the companies like Huawei would be affected, but most other companies, 99% of companies, are not going to be affected because they can easily use these chips. And if China can mass produce 28 nanometers and 14 nanometers, especially with all these new factories and all of hundreds and thousands of chip companies that are opening every year all around China, I'm pretty sure they can hit that 70% figure by 2025, and I'm pretty confident of that. So the fifth and final thing that China is focusing on is future technology, and this is currently new technology which the world has not yet focused on. And there are a number of options that China will be able to do, because if they start with this new technology, they would be at an even level with a lot of other companies around the world, because the Moore's law is, we're reaching it right at the end now, and there's only so much you can do with Moore's law. So now you've got to look at different ways of doing things, and there are a number of different ways. One of them is basically using a technology called gate-all-around, FETs. Currently a FinFET technology is being used, but a gate-all-around FETs is where a FinFET is placed on its side and a gate is wrapped around it. So this is a new type of technology that can be used for beyond 3 nanometers. There's other technologies you can use as well. There's one called graphene, and there's a couple of ways you can use graphene, and this is one way which is quite ingenious actually. The MIT research team involves graphene where single atom thin sheets of graphite are being used to copy intricate crystalline patterns from an underlying silicon wafer onto adjacent top layer of identical material. So it's called graphene photocopying. So you can basically get a chip and photocopy it using graphene. So this is a brand new technique which has been tested around the world. So that could be one way. So what is graphene? As you can see here, the discovery of an atom-thick layer of graphene by 2 researchers at the University of Manchester in England stoked expectations that it could become a superior replacement for silicon. Graphene's properties have companies across industries salivating. Its mobility is estimated to be 250 times that of silicon, and its flexibility and other properties make it an ideal range of applications, from battery technology to optoelectrics such as touchscreens. Recent patents, academic papers and research publications testify to the widespread interest of graphene. So why hasn't the world gone to graphene? As you can see, it's not that easy. An integrated value chain including manufacturing, midstream, retooling exists for silicon, but billions of investments is needed for recreate one for graphene. So a lot of the top companies like TSMC, Samsung, they've already invested billions for it to work with silicon. So for a new company, especially a Chinese company, if they invest a lot of money into creating a very similar manufacturing chain, supply chain for graphene, I believe they could be in the driving seat in the next few years. Graphene is also being tested by Huawei as well. They're using Huawei to test graphene, and basically graphene can replace silicon in these transistors. So graphene is a lot more conductive than silicon is, so graphene could be one way. Another way is gallium nitride, GaN, and gallium nitride could be used instead of silicon, and that's another method that it can be used. And why is gallium nitride so important? You can see here the bottom line is gallium nitride technology can handle larger electric fields in a much smaller form factor than conventional silicon, while delivering significantly faster switching. In addition, gallium nitride technologies can operate at higher maximum temperatures than the silicon counterparts. So you can see gallium nitride can provide much more advantages than a silicon can. Then you also got graphene as well, graphene, the next S-curve semiconductors. And graphene is a new technology, and currently it's being tested by companies such as Huawei. And the problem with graphene is there's not a supply chain of graphene at the moment. There is not a big amount of graphene being produced around the world. So once graphene is starting to be mass produced around the world for a cheap price, I believe that would take over silicon. The reason silicon is so cheap is widely abundant around the world. It's basically sand. You can extract it from sand, so that's why it's so cheap. And once cost of graphene to build graphene goes down, and graphene is starting to be mass produced, you will see a lot of companies which are probably turning to graphene for their semiconductor needs. And currently Huawei is focusing on graphene chips at the moment, and they are trying to build their own supply chain with graphene in terms of producing graphene and also testing with graphene chips as well. As you can see, Huawei revealed a new patent in the field of semiconductors and graphene field effect transistors. And a lot of people don't know much about Huawei. Huawei is not publicly funded in the stock exchange, doesn't have shareholders it needs to please. Huawei shares is split between its employees. So all the employees have a right or have it within their heart to do everything they can to help Huawei, because Huawei doing well means they do well. So all the employees have a responsibility to work as hard as they could to make sure Huawei doesn't die and Huawei is able to produce new technologies to survive. And all of this has basically kicked Huawei up the backside, and they realize that they need to be self-sufficient, and I'm sure they're doing everything they can to be self-sufficient. And Huawei is one of those companies which is happily sits in the background until it comes out with a breakthrough, and then wow, it's hit the world, and the world is like, wow, where did that come from? For example, 5G, when Huawei first came out with 5G, the world just didn't know how to deal with it, because and America was obviously quite scared with the technological growth of Huawei, and they tried to suppress it. However, they cannot suppress a company like Huawei with the way they work, and they're happily sit in the background until they come out with a breakthrough, and they will continue, and they'll come back with a big bang. And all of this has kind of taught not only Huawei but China to be self-sufficient. You cannot rely on America and other countries. You got to rely on yourself. So Huawei will come back with the new technology. The good news is, companies like TSMC, Samsung, they've already invested billions and billions, because these machines, EUV machines, they cost 1.2 billion each, and they use the FinFET technology, they use silicon wafers. So a lot of these companies have already spent billions and billions on the existing technology. But with Moore's law, it's coming to an end. How long? It's not going to last very long. It's probably give it another 5 years, 10 years. But if you want to move ahead in the world, you got to focus on new technologies. And right now, if Huawei focuses on graphene, builds up a very good supply chain of that graphene, where it can produce its own graphene and use graphene for its own semiconductors, and use its own machines, DUV machines, EUV, or other kinds of laser lithography machines, Huawei would be in a great position. It'll be even better positioned than companies like TSMC and Samsung in the future, because Huawei would have already built this great graphene supply chain. And companies like Huawei can focus on things like that, because there's no shareholders pushing them for accounts and budgets every year. So they can sit in the back and do things like this, and then come out with a breakthrough. So yeah, I just wish them well, really. So let's kind of catch up in the next few years, see how they get along. I'm not saying they'll be successful or not, and it's definitely not going to be easy. So forget about Huawei for a second. Let's talk about China. In general, look guys, I'm going to be honest with you. It's not going to be easy. It's not an easy technology. And this is going to be the biggest test, the biggest challenge China has ever had. This is even bigger than nuclear weapons. This is even bigger than building jet engines, because the current EUV machines is the highest form of technology a human has ever produced. So creating this supply chain, creating these machines, creating semiconductors is not an easy thing. Plus, as you know, Moore's law is coming to an end as well. So it is coming to an end. So there is issues, especially with the trade war, where China is not able to buy machines to do this, so they have to make it all themselves. So there are issues out there. Issue with the supply chain as well. Issue with talent. There's not much talent out there in China. They're having to get a lot of talent from Taiwan, but now I believe that's banned. So there are a lot of issues. It's not going to be easy, but it is the greatest challenge that China has ever had. But then again, China has overcome all its greatest challenges had over the last 20, 30 years. So I, for one, I'm not going to bet against them. So let's see how they do over the next few years. It's not something that's going to happen quickly. It's going to take a few years at least. But one step at a time, guys. As you know, they've got 28 nanometers in the bag. They're mass producing more chips than any other country. They are getting better and better at producing chips. 28 nanometers already been mass produced. Factories being produced all over the place. Hundreds and thousands of chip companies opening. They got 14 nanometers coming out next year. And plus, SMIC has got a 7 nanometer product as well, the N+1, I believe. So that's going to come out in the next few years. So slowly every year they are getting closer and closer, narrowing the gap. But obviously it's going to take time, but step in the right direction. But the main thing is, guys, they are working on these 5 major steps. They're working on their supply chain, they're working on the equipment, they're working on the talent pool, they're working on the manufacturing, they're working on the mass production, and they're also working on future technology. And the future technology, they are also quite ahead on some fields like AI, quantum, things like that. And sometimes, using these semiconductors that are going to go beyond 1 nanometers, you need things like AI and quantum, and China is pretty much racing ahead with those fields, even further than America, I believe. But anyway, let me know what your thoughts are, guys, and let me know what you think, and I'll chat to you in the comment section. Don't forget to like, subscribe, share whatever you can to help support the channel. If you really like the channel, if you really want to support what I do, then don't forget to buy me a coffee or join my Patreon. So thank you very much, guys, and I'll see you in the next video.